Hello friends. It was March 2003 when a 44-year-old man named Andrew Carlson was arrested by the FBI under unusual circumstances. Reports claimed that he possessed extraordinary luck and had earned an unprecedented amount of money in the stock market. With an initial investment of $800, he managed to turn it into $350 million within just 2 weeks. The FBI suspected him of running a scam and engaging in insider trading. However, when questioned, Carlson shocked everyone by claiming to be a time traveler from the year 2256. According to him, he had knowledge of future stock market performance, which allowed him to make such incredible profits. Naturally, the FBI was skeptical and took it upon themselves to investigate Carlson's background. To their surprise, they found no records of his existence before December 2002. Additionally, on April 3rd, when Carlson was supposed to appear in court for a bail hearing, he mysteriously disappeared and was never found again. This intriguing story raises questions. Was Carlson a real time traveler? Is time travel even possible? Or is it confined to the realms of fiction? In this video, we will explore the concept of time travel from a scientific perspective. The idea of time travel gained popularity with H.G. Wells' 1895 novel, The Time Machine. While Wells' work was a fictional science fiction novel, it inspired philosophers and physicists to delve into the possibility of time travel. Different types of time travel can be classified based on how it is portrayed in literature and films. The first one is one-way travel to the future. This type of time travel involves traveling to the future but not being able to return. The movie Interstellar illustrates this concept, where a time traveler journeys to the future, while his family and acquaintances age and even pass away. The next is instantaneous time jumping. This form of time travel allows a person to jump from one point in time to another instantly using a time machine. Films like Back to the Future and The Girl Who Leapt Through Time portray this type of time travel. Then comes time dilation. In this concept, the time traveler remains stationary while time moves around them. Harry Potter and the Prisoner of Azkaban depicts this when Hermione uses the time turner to go back in time. The fourth one is slow time travel. This type of time travel involves the time traveler entering a state where time passes differently. The film Primer illustrates this concept, where the time traveler spends time in a box, and for each minute inside, they go back in time by a minute. And the last one is traveling at the speed of light. This concept suggests that traveling faster than the speed of light could enable time travel. The movie Superman depicts this as Superman flies faster than the speed of light and travels back in time. Among these concepts, which ones are scientifically plausible? Let's explore this in today's video. Broadly speaking, there can be two types of time travel. One is to travel into the future, and the other is to go back into the past. Let's talk about traveling to the future first. Traveling to the future can be scientifically explained through Albert Einstein's theory of special relativity, particularly the concept of time dilation. One of the most famous mathematicians and physicists in the world, Sir Isaac Newton, believed that regardless of the speed with which you're traveling through space, or regardless of the position, the flow of time would be constant. Einstein challenged this belief, stating that it can vary based on speed and gravity. According to time dilation, the faster an object moves, or the closer it is to a gravitational source, the slower time passes for that object relative to a stationary observer. This means that time is relative and can be influenced by different factors. Yep, you heard it right. Time can actually be sped up and slowed down if the speed and gravitational force could be changed. How had Einstein actually discovered this? We can talk about this in some other video. It's a very long explanation, and so I won't go into that right now. Basically, time dilation can be done in two ways. The first is with speed. If you are sitting in an object that is going very fast, like an airplane or a spacecraft, the faster it goes, the more would time slow down for it, relative to a person who isn't going as fast. For example, if two clocks were synchronized and one clock was sent on a high-speed journey, lying in an airplane while the other remained stationary, upon their reunion, the moving clock would show a slightly slower passage of time. I am not making this up. This has been experimentally verified with atomic clocks in the Half-Keating experiment of 1971. This is known as kinematic time dilation. This had proved Einstein's theory of time dilation. Theoretically speaking, if we could build a rocket that travels at the speed of light, and you get in that rocket and you remain in that rocket for 10 years traveling at that speed, and then you return to Earth, the time that you see on Earth would be 9,000 years to the future. Simply speaking, if you want to travel into the future, you can already do it now. It is scientifically possible to do so today. The only problem is that there isn't an aircraft or any technology that travels at this speed. But with improvements in technology, we may build more such aircraft and spaceships that can fly faster. For now, Gennady Padalka, a Russian astronaut, is credited with the most time travel into the future, and it's because he remained in space the longest, that is, 879 days, where he was traveling at the speed of 28,000 km per hour in space, which means he has traveled 0.02 seconds into the future. There's another way of time dilation as laid down by Einstein, that is by using gravitational force. Similar to time dilation with speed, gravitational force also leads to time dilation. More the gravity, more would be the time dilation. The time dilation that takes place because of gravity. To visualize it, Einstein asked us to imagine a fabric of spacetime. Imagine a mesh, like shown in this photo, and let us put balls on it. You can think of these balls as planetary objects. The heavier a ball would be, the more this mesh would get wrapped. The more mass in the ball, in the planetary object, the more would be its gravitational force. Earth's gravitational force is less than Jupiter's, while Sun's gravitational force is more than Jupiter's. Similarly, in the fabric of spacetime, you get to see a curve with the gravitational force of an object. The closer you get to an object with a high gravitational force, the more would you feel time slow down. In this mess, you can see, the steeper the drop is, the more time slows down for you. You can have an approximate estimate with this visualization. This basically means that if you want to travel through time in the future, spend some time near Jupiter, or around the Sun, or near an object that has even more gravitational force like a black hole. If you spend some time near a black hole, time would pass very slowly. This is the same concept shown in the film Interstellar, if you remember. The main character in it lands on a planet near a black hole, and each hour he spends there, it's 7 years for the people on Earth. It is a scientifically accurate depiction. But whether someone can survive being that close to a black hole is unknown. It's said that black holes are the heaviest objects in the universe, and light starts bending around it. This was considered to be purely theoretical, but on April 10, 2019, the Event Horizon Telescope clicked this picture and proved it. This photo went viral on the internet because this is the first rendered visual image of a black hole. Anyway, let's get back to time travel. I told you 2 ways of traveling into the future. The first is to travel at a high speed, and the second is to get very close to a gravitational object with a high gravity and a high mass. I would like to give you another example of this, the GPS satellites that keep revolving around the Earth at a high speed. They are farther than Earth's gravity when compared to us, and that's why we get to see time dilation in the GPS satellites, due to both speed and gravity, and the scientists need to update the time on those satellites because of this time dilation. If they don't rectify the clocks on the satellites, then the time on those clocks and those on Earth will differ, and therefore, there would be problems with GPS communication. Interestingly, friends, there is a third way of time traveling in the future. It is known as cryosleep. This is a technique where people are frozen for months or years. It has been shown in many films like Captain America: The First Avenger. Humans are put into a condition where they don't age, they remain asleep. It's a science fiction, but in reality, NASA is trying to develop a stasis chamber where astronauts will be kept in a state of mild hypothermia in a cold environment where the astronauts will be able to sleep continuously for 2 weeks, like a hibernation. The concept behind it is that when a body is kept cool, the chemical reactions in the body would slow down to quite an extent. This would lead to energy conservation in the body and would slow down aging. There was a case in Japan related to this. An injured man survived 24 hours without food or water when his body went into a state of hibernation. The temperature of that man's body was only 22 degrees Celsius. Normally, if a human body is this cold for a long time, it may lead to death, but by chance, I don't know with what miracle, not only did this man survive, but also, he made a full recovery from that mode. After his body was discovered by someone else, medical reports claimed that there was no permanent damage to his body. His organs had slowed down and his brain was unharmed too. Cryosleep is something which may be developed in the future by NASA or some other space agency. We'll have to wait and watch. If you think that you are getting to know something new from this video, please consider to give it a like and hit the subscribe button. And now let's get back into the video. Have you noticed one thing? The ways I have told so far were all related to travel to future. What about the past then? Can we really travel into the past? As of now, we can't travel into the past, but we can get a glimpse of the past. Getting a glimpse is possible because it takes a significant time for light to travel from one place to another when we talk about distance in light years. It takes years for light to travel to some places, so if we could get somewhere before the light reaches there, and then look back at the approaching light, the light would be from the past, and that is how we can see the past. Can we actually travel through time into the past? As of now, I don't think so. If it were really possible, we could have heard of a lot of time travelers coming from the future. On June 28, 2009, world-famous physicist Stephen Hawking hosted a party at the University of Cambridge. There were balloons and champagne at the party, but what was special about the party was that, though everyone was invited, no one attended. Stephen Hawking had hosted this party for time travelers, and if a time traveler was visiting our timeline from the future, they were welcome at that party. This comedic experiment was conducted to prove that it isn't possible to travel to the past. If there are travelers traveling to the past, why don't we meet them? Theoretically speaking, Einstein's theory of relativity doesn't disprove time travel to the past. Einstein had said that in a mesh of spacetime, if a huge gravitational force is put on it so that the object falls through the mesh, it would create a wormhole. We can use that wormhole to travel into the past. It said that to do this, we'd need an extremely powerful gravitational field similar to the one of a black hole. Perhaps a spinning black hole can generate so much gravitational field that it bends the curvature of the spacetime back on itself, and it would create a close time-like curve known as CTC. Nobel Prize-winning physicist Kip Thorne believes that small wormholes get created and then disappear in space all the time, but they are really small, even smaller than atoms, and if we want to travel through them, we would need to open them up somehow. It would take a lot of energy to expand them, not only normal energy, but we would need negative energy also. Negative energy is a kind of anti-gravitational energy that would repel the fabric of spacetime like the same poles of magnets repel each other. This would make it possible to keep the wormhole open for a long time, so that we can travel through it. How would this negative energy be harvested? How would it be created? It's something to think about, and so this is purely theoretical for now, but it is a theory by a Nobel Prize-winning scientist, so it holds a lot of weight. With this, you may think that it might be theoretically possible to travel to the past, but when we talk about traveling to the past, there are a lot of hurdles and obstacles. Here I'm talking about paradoxes, such as the grandfather paradox. The paradox goes like this: suppose I go to the past and I kill my great-grandfather. If he dies, how would I be born? If my great-grandfather died, I shouldn't be alive, and if I was never born, I never existed, then how could I have gone to the past and killed him? How do you explain this? This is a paradox. Either I'm alive or I'm not, and this goes against logic. There are some theories to explain this, such as the theory of multiverse. The theory claims that what happened once was in one universe, but when you travel back in time and change something, it would create a new universe, creating a multiverse. This concept was shown in many films like Avengers Endgame.
If we can do this, go back in time. Why don't we just find baby Thanos, you know, and...
Time doesn't work that way. Changing the past doesn't change the future.
There are multiple universes with different things happening, and for every choice we make, we create a new universe. The existence of multiverse is not proved yet, but there are a lot of theories behind it. Then there's another paradox, the predestination paradox. It claims that when I go into the past and do whatever, everything I do shapes my present timeline. This paradox claims that things are destined to turn out in a certain way. Things will play out as written in destiny, no matter how much you try to change the past, and whatever you try to change would be your present. If you're confused, let me give an example. Suppose your friend meets with an accident and he dies. I hope it doesn't happen. This is only for an example, but imagine that it happens, and you have a time machine with the help of which you go into the past and try to prevent that accident from happening. But what actually happens is by going into the past, you have done something that actually caused the accident, and then you find out that it was because you went into the past and you tried to prevent that accident, you caused the accident. This was the concept in many films like 12 Monkeys, Time Crimes, The Time Traveler's Wife, Predestination. The Heisenberg effect becomes very much relevant here because it introduces uncertainty into the measurements and predictions of events in the future. If someone were to travel through time in the past, their actions and presence in the past could potentially disrupt the normal course of events, leading to unpredictable consequences. The uncertainty principle implies that the very act of observing and measuring events in the past would introduce uncertainty and change the outcome. This suggests that time travel could be inherently unpredictable and uncontrollable, as any attempt to precisely measure and observe events could alter them in unforeseen ways. Therefore, the Heisenberg effect adds a layer of complexity and uncertainty to the concept of time travel in theoretical discussions and science fiction. Overall, there would be many logical problems when traveling to the past. There would be paradoxes, and due to these, it may never be possible, but traveling to the future, it is possible even today, and it will become more and more probable in the future, and to get a glimpse of the past is currently possible too. So in a sense, time travel already exists, and as shown in films like Interstellar, it was the scientific truth to an extent. Then there's cases of time slip or time jump where people claim that they have traveled into the past or future for a few seconds before coming back. There are even stories where people claim that they have built a time machine, but my friends, there are no scientific evidence or proofs behind those stories. But what about Andrew Carlson's story? I didn't say much about it because the story that I told you at the beginning of the video was actually a story published in a satirical newspaper called the Weekly World News. Later it was printed by Yahoo News, and several other media organizations reported the story as if it were fact. But the truth remains, that story was a satire. It was fake news that was circulated in newspapers, and people believed that it was true. I hope you found this episode informative. Let me know that you think about these time-traveling stories in the comments down below. On which other topics would you like to watch more videos in the future? Let me know that too in the comments below. Thank you very much. Until then, keep learning and keep growing. Goodbye.